So welcome, I'm looking at example 3-8, so you'll find that file. If you want to grab that file, you'll see the link below. Just click on that link, and then from there click on chapter 3, and then you'll see this is 3-8. So it's like the last one that we looked at, the 3-7. This is basically an expansion of that, and this becomes the allocation problem, which is instead of before, in the Goodman problem, we had one truck. Now we have the possibilities of, well, what about having two trucks? Is it worthwhile to, instead of having one big truck, have two smaller trucks? All right, so I've copied this onto this other sheet. Okay, and the reason why is if I make any mistakes, I can always refer back to the original. So what I want to do is I want to start blanking things out. So I want to blank out the optimal number. All right, so we can blank that out. And the amounts in terms of the value per pound hasn't changed, right, for each of the items. So we still have the same items, so we don't have to blank those out because these will be the same as before, all right? So we don't have to change those. But we should, blank out the formula just so we can start from scratch. We can blank out these formulas here, all right, so that we start from scratch. And we can blank out here, all right? So I'm not going to blank out the limit because that hasn't changed from the previous question. So the limit is still there. Okay, but in terms of the same weight, I'll blank that out and I'll blank this out because that's a new constraint. Okay, so let's take a look and I'll just blank this out because this is our second vehicle. All right, just take that out. So I've left all this here because this is pretty much the same idea as before. I'll blank out the same weight because that's a new kind of constraint. So I left you with everything that's old. So things that haven't changed. So everything here are the things that haven't changed compared to before, which is in terms of item 1, we only have 5,000. Item 2, we only have, in terms of pounds, 4,500 and so on. So that hasn't changed. The volume of the actual item hasn't changed, each item hasn't changed. Okay, the weight limit has changed though. So in terms of the weight limit, we're with two smaller cars. So before, or sorry, two smaller trucks. So before it was 15,000, now it's 10,000. All right, so it's 10,000. Now the trucks are identical. So I can also go into here for the trucks and I can put 10,000 for here. But the because it's a smaller truck, it has a lower weight limit, so we can't take as much weight. It also has less capacity. So in terms of capacity, in terms of cubic feet, it has 900. But these are the same size vehicles, right? So it has the same capacity. So the two vehicles are identical for that, and that's what it says in the question. So over here we got the weight limit for truck 1 and the volume limit for truck 1, and just below we got the weight limit for truck 2 and the volume limit for truck 2. Now, because everything is symmetrical, we can grab this here, we can copy it, but we wouldn't put it here, we would put it down here like so, and you can see that it's lining up with weight limit for truck 2, right? And then item 1 in truck 2, so it corresponds to that. All right, all the rest, so truck 1 stuff here won't interfere because this will all be zeros, right? It'd be just adding a bunch of zeros here. Just like for this one, truck 2 doesn't interfere because you'd be going across adding zeros to that, which doesn't make a difference. All right, so we can do our sum product. All right, so we can do the sum product. All right, so we open up the bracket here. All right, so we would take this array across like so. And then we would take the decision variables, which is how much we're going to take of each item going across here. But again, this is something that is not going to change. This is not going to change. All right, so we highlight that, and then I hit F4, and then I just close that bracket like so. Okay, so, and then I can copy that down. All right, so I can copy that down. Okay, like so, and I got the sum product. In fact, I could take that and I can copy that up here as well. And just double check that it would be, okay, so it'd be, and this would be in terms of the load value. Now, one thing I did do is I changed the color. I need to have this green just to draw our eyes to it. Okay, so that's going to draw our eyes to it. All right, so again, I'm trying to, just like one before, I'm trying to maximize the value of 2 trucks leaving as opposed to just 1 truck leaving. Okay, so let's see what else we got to do. So the item 1 limit in pounds. So item 1 can leave on either truck 1 or truck 2. All right, so we can take this, right? We can go across to right here. Right, so this can go, all right, and then if we go across to here, it's saying that we can take item 1 either with truck 1 or with truck 2. Right, in fact, I can take this and I can copy, and we just make sure that it's all lining up. All right, and then you can just do a test. And item 2, right, is going, it can either go into truck 1, item 2, or item 2 can go into truck 2, right? Some combination of that. All right, and that looks like it's lining up. Now, in terms of the same weight, we got to figure out the weight of each. We got to equalize that. So we can get the amount here. So this would be item 1, right? And then the weight of item 2, and then the weight of item 3, and so on. So we can copy that across. Okay, like so. And again, with the sum product, if we tap on sum product, it would be the amount of item 1 times 1 plus the amount of item 2. And again, the amount is in pounds. So as we add that across, that will give us the total amount of in our truck. All right, in terms of the weight there. And you can see that that's identical to the weight limit on that truck here. All right, so you can see that that's the weight limit on that truck here. Now, we don't want to keep doing ones across here because then it's going to be adding up the weight of both trucks together. But we want to equalize that. But the weight of all the trucks, all right, will be coming across here. Right, so truck 2 will be coming across here. So what we can do is we can title this and make that equal to the sum. Right, so we can do a sum and then bracket of all the weight that is in truck 2. Click on there, close off that bracket like so. Okay, and for some reason it's blue. Let me just do no fill on there. There we go, just because it's not a left-hand constraint. And then we want to have an equal sign. So we want to have a constraint that they're equal to each other. All right, so let's try this out. Let's try this out. Now, what we want to look at is it worthwhile to go with 2 trucks? And what we got to compare is, well, how much more value do we get in terms of dollar value from having 2 trucks leave and dollar value? But of course, it's going to drive up our costs. What it says in the book is that costs are going to increase. The operating costs are going to increase by 5,000. So what we want to do is looking at the added revenue we get minus the added cost. Is it worth it? All right, so let's go into Solver. Let's click on this cell here and then go into Data and then go into Solver. All right, so we're going to be maximizing, and it is N6 on here. And we want to do that by changing the variable cells. Don't have a lot of space. There we go. Just go across like so. Okay, and then subject to the constraints. So the constraints, nicely enough, are all right here. So let's add a constraint. Now these are all less than or equal to, except for that last one. So we can do this for the left-hand side. And then we can do the right-hand side. All right, like so. And we can add that in. And then we got the last one, which is the making sure that the trucks have fairly equal load. You know, we don't want to have one truck that's always getting more wear and tear than the other. So we take that and then we switch this over to equals, because that's a constraint as well. And we want to click on that one there. All right, then we can press OK. Okay, put that to simplex. And we'll go from there, solve. So what you'll notice is I have the same value in terms of the amount made by running the two trucks, as in the example here. Right, so this is the example from the textbook. But what you'll notice is the example from the textbook, item 3, 4, and 5 is empty. Well, for mine, item 3, 4, and 5 is not the same. So there's more than one way to do this. Now, what's kind of cool is we can go on to the original one. Right? So this is the original problem. We can blank that out like so, and then go into solver, and then solve it again. And press OK. Okay, and what you'll notice compared to the textbook, it's changed again, but what hasn't changed is in terms of the value. And also what hasn't changed is in terms of how much they're taking of each. So if you look at mine, they're taking just as much as before, but they're able to shift that. So there's more than one way, I guess, to load those two trucks, but the value is the same as that. So that's kind of an interesting thing to look at, and that is we can take the solution, run solver again, it will find the same amount and it'll meet those constraints, but it's going to shift some of the loading a bit differently onto the trucks. But again, as you can see, truck 1 is maxing out its weight and maxing out its volume. And same thing for truck 2 is maxing out its weight, maxing out its volume. So there's more than one way to do that. You can see even, so if you do this and your answer doesn't compare to mine or to the, it doesn't compare to the answer key, then you'll notice that it's because you can look at the answer key, run it again, and you'll get a different answer. So it's kind of an interesting way that there's more than one way to reach that optimal amount of value for the two trucks. But it looks like the optimal amount doesn't change, right? So it doesn't change. And as well, the amount that you should be taking of each product doesn't change. But where it goes into the different trucks, that does have the flexibility. All right, so that's what I'm looking at for the example for 3-8. Thanks for watching.